Hi guys, today is March 30th, okay? So today's gonna be integration and completing the square. So the last 2 days, what we've done is we've looked at really specific integration techniques, okay? And even today is gonna be a special one. We're gonna use completing the square, all right? So I wanna review completing the square with you guys first, okay? So x squared plus 8x plus 19. Remember, completing the square means making a square. So x squared, we start with this, so x squared, right? And I'm gonna make an x squared. We do the area model. So x squared, right? Okay. And then off of that, remember to build a square, we need this side and this side to be the same amount, right? So and these are our x terms. So we're going to put half of them here and half of them here. So remember me writing this last year or in math 2, okay? We're going to put half of 8x here, right? So that would be 4x here and 4x here, okay? Now, what are we going to need to make this square? We're going to need this piece right here. Well, what is that? Okay, what is that piece right there? Well, this is x by x, and if that side's x and this area is 4x, this side would have to be positive 4, and this side up here would also have to be positive 4 to get the 4x, okay? These two sides must be the same to make a square, right? So 4 times 4 is 16, so we need 16 right here. So this little piece that we need to add is 16. Now, I'm going to do this a little bit differently than we've done in the past, okay? I'm going to break the 16 up, okay? Usually I added 16 and took away 16, okay, and to the plus the 19. I'm going to do a little bit differently. I'm going to break this one up, okay? It'll just make it a little bit easier when we do our problems, okay? So this becomes x squared plus 8x. And instead of 19, it's called decomposing 19, but we're going to break 19 up into two pieces. One of them is going to be 16, so plus 16, because I need the 16 to make the square, but I don't have 19 anymore. So what I need to make 19 is I need to add 3 to this. So really, in essence, we have the same thing, right? We have x squared plus 8x plus 19. We have x squared plus 8x plus, and then this is 19 right here, okay? Now, these three pieces make the square. So this becomes the x plus 4 times x plus 4, or x plus 4 squared plus 3. And you see how we did it in 2 lines? What allowed us to do that in 2 lines is we decomposed the 19 into 16 plus 3, okay? All right, so if we go over here to this next problem, okay, we have x squared minus 6x plus 11. Okay, I want to use the x squared minus 6x to make my perfect square, okay? All right, so here's my x squared, okay? And then I'm going to put half of the x's right here and the other half right here. I'm going to just draw this in right here. And we're going to put half of negative 6x in each of those, okay? So that would be negative 3x and negative 3x. And then this one's x by x. And if that side's x and this area is negative 3x, this side would have to be negative 3. This side would have to be negative 3. And negative 3 times negative 3 is positive 9. So this little part right here that we're going to need to add is 9. All right. So back over here. Okay, so how can we rewrite this? We want to decompose this 11, or we want to break it up, right, into two pieces, one of them being 9, right? So we have x squared minus 6x plus the 9, but I need 11, so I need to add 2 to that. The x squared minus 6x plus 9, these three pieces together make up my x minus 3 squared, and then plus the 2. Okay, so that's the first 2 on reviewing completing the square. For these next 2 review problems, okay, what we have to do first is we're going to have to factor something out because we're not starting with x squared. Okay, so for this first one right here, what I want to do is, because if we're starting with a negative x squared, whatever this is right here, we're going to want to factor that out of all 3 of them, okay? So I'm going to factor that out, and I'd have negative and then parentheses x squared plus 8x plus 11. Okay, so now I can complete my square with x squared plus 8x plus 11. So I'm going to make my square, and it's x squared. And then off to the side here, I'm going to add the left, or not the left, the right and the bottom, okay? And what are these two pieces, okay? These two pieces have to be half of 8x. So this would be 4x, and this would be 4x, okay? And then factoring this would be x plus 4, and this would be x plus 4. And 4 times 4 is 16. And that's the piece that's missing right here, right? That's 16. Okay, so I need to break this 11 up into, and I need 16, right? Well, 11 is less than this, right? So I'm going to have to actually subtract to get from 16 back to 11. Okay, so this becomes negative, and then parentheses, x squared plus 8x. But instead of writing 16, or not, instead of writing the 11, I need to write 16. But now I don't have 11, right? So what do? Well, I need to subtract 5. Okay, so then these three terms right here is what's going to make the square, okay? So I have negative parenthesis, and this becomes x plus 4 squared. Now, this is minus 5, right? But I'm multiplying by a negative, so it actually makes positive 5. Okay, and then the next thing I want to do is I'm going to rewrite this as a subtraction problem. You're going to see in a few problems, when we start getting to actually doing problems, you're going to see this is going to need to be rewritten. Okay, so it's going to be 5. We would write this as 5 minus x plus 4 squared, because that form is going to actually help us to understand the different pieces that we need. Okay, so then this next problem, we have 3x squared plus 18x plus 39. What I want to do is factor out the 3 out of all three terms. All right, so I'm going to factor out the 3, and I'd be left with x squared plus 6x plus 13. Okay, so now I can, because I have x squared here inside the parentheses, I can begin to complete the square. So I have an x squared, and then off to the right and below the x squared, these two pieces have to be the same. So I'm going to put half of 6x. Okay, so that would be 3x and 3x. And then factoring it, that'd be x plus 3 and x plus 3. These two always have to be the same because it's a square. All right. And then what's the piece that's missing? The piece that's missing is 9. So that's this little piece. That's the piece that we need to complete the square. Okay. So that's 9. All right. So this 13 needs to be decomposed, needs to be broken up. So this is 3 times x squared plus 6x plus the 9, but I don't have 13 anymore, right? So I need to add 4. Okay. And then these three pieces, along with multiplying by 3, makes up the square, right? So this becomes 3 times x, and these 3 make up the x plus 3 squared. Now we don't really have 4. We have 3 times 4. So we need to add 3 times 4, which would be 12. Okay. All right. So that's the review on completing the square. I kind of gave you 4 different problems to look at. Okay. And let's start doing some problems. Okay. All right. Before we get to some problems, we need to figure out what is this integral. Okay. So we know that the integral of 1 over 1 plus x squared dx. Okay. We should recognize that that's the derivative of arctan x plus c, or tan inverse of x plus c. Okay. So let's write tan inverse of x plus c, right? Okay. But what about this? What if you have 1 over a squared? What if this, like, if this was 1, okay, we would know what to do. But what if it's something else? What if this is like 3 squared, or 5 squared, or anything else squared, right? So it turns out that it's also arctan, okay? Because you can complete the square and get to and rewrite this so it looks like this, okay? But we don't want to have to do that process. So is there a quick way? So this is basically a formula that we need to know, okay? And when we see this format, okay, we know to rewrite it like this, like that's the antiderivative of this, okay, function. All right, so what we're going to do first is we're going to take 1 over a squared plus x squared, and we're just going to rewrite it first, okay, because I'm going to multiply by something. Okay, so 1 over a squared plus x squared, okay, times, all right, and what I'm going to want to multiply by, all right, is I want to make this become 1. So I'm going to multiply by 1 over a squared, the bottom and the top. Because what is 1 over a squared over 1 over a squared? Well, it's the big one that we've talked about, right? Okay, so this is dx. Okay, so then this becomes the integral of 1 over a squared over, okay, now when I take 1 over a squared times a squared plus x squared, it's going to be 1 over a squared times a squared. That would give us 1, and then plus, and then multiplying 1 over a squared times x squared would give me x squared over a squared, and then our dx, right? But this could be rewritten, okay? So this could be rewritten as x over a squared. Okay, that's just an exponent rule. So now we have the integral of 1 over a squared over 1 plus x over a squared dx. Okay, so now it's starting to take on this form, right? So we've gotten this 1 here, right? And we're squaring something. Okay, so we're squaring something, but it's not x, right? It's not like this. So that this is a perfect example of integration by substitution. So we're going to let u be this x over a. Okay, so u is going to equal x over a, or that's equivalent to 1 over a times x. And I should have said this earlier, this a is a constant. It's going to be like a number like 5 or 9 or 16 or 17 or the square root of 3, okay? It can be a lot, it's just a constant, okay? All right, so this is 1 over the constant plus x, okay? All right, now what's the derivative of that, okay? So what's our du? Our du is just 1 over a times dx, right? 1 over a, the constant, times the derivative of x, so that'd be dx, okay? All right, now, right here, we have an extra a here, right? We have 1 over a squared. We just need 1 over a. So I'm going to break this up, okay? So now this becomes the integral of 1 over a times 1 over a over 1 plus x over a squared dx. And this 1 over a, along with the dx, is going to make up this du here, okay? Now, what can I do with this 1 over a? Now, remember, a is a constant, so it's just going to come out. We can bring it out in front, okay? So let me slide this up. Okay, so this 1 over a right here is going to come out in front. So 1 over a times the integral of 1 over a times dx, right? Which becomes my du. So it's really going to be 1 over, and this is going to become 1 plus u squared. And this 1 over a and this dx makes my du. And now we can recognize it. This is the antiderivative of arctan, but instead of the x, we have u, right? Okay, so this becomes 1 over a times tan inverse, or arctan, tan inverse of u plus some constant c. All right, now what is u? Well, it's x over a. So this is 1 over a tan inverse of x over a plus c. Okay, what did we start with over on this side, right? It was the integral of 1 over a squared plus x squared dx. Okay, so when we see this, we can rewrite it like this, okay? And so it's whatever number, it'd be whatever number we're squaring here would be the denominator here and here, and whatever value of x, okay, that we're squaring here would go right here, okay? All right, so a general form of this, okay, using integration by substitution, okay, it would look like this. The integral of, this is kind of like more of the antiderivative rules and derivative rules, okay? 1 over a squared plus u squared du would always equal 1 over a tan inverse of u over a plus c. And that's the general form, okay? And so that's what we need to know. Okay, so a is our constant term and u is going to be our variable. Okay, that's where our variable is going to be. Okay, it's going to be something with a variable squared, something with x squared. Okay, all right, let's do some problems now. All right. For this first example, we want to find the integral of 1 over 1 plus the quantity x minus 3 squared dx. Okay, so what we need to do is we need to recognize it takes on that form, okay? So this is the integral of 1 over, okay, what number is being squared here to get 1? Well, it's 1, right? So 1 squared plus x minus 3 squared dx. And what this tells us is that our a is 1 and our u is x minus 3. Okay, so that means this becomes, from that formula that we just learned, okay, it's going to be 1 over a, but our a is 1, so this would be 1 over 1 tan inverse of u, which is x minus 3, over a, which is 1 plus c. Now we'd want to clean this up a little bit, okay? So this was a nice problem that we could clean up because a is 1, all right? So 1 over 1 is just 1. So this is really just tan inverse of x minus 3 over 1, which would be x minus 3 plus c, okay? And that's example number 1. So example 2, I want to find the integral of 1 over 4 plus the quantity x plus 5 squared dx. And we have to recognize, okay, what number is being squared here? Okay, so I'm starting out with some like simple basic problems and we're building up to harder and harder and harder problems. So we're always going to want to get it into this form, because if it's in this form, we're going to be able to look at it and go, oh, this is my a and this is my u. Okay, so this is equivalent to the integral of 1 over, and 4 could be rewritten as 2 squared, so my a is 2 in this case, plus x plus 5 squared, okay, and then dx. So from this, I can tell my a is 2 and my u is x plus 5, okay? And so this is equivalent to 1 over a, which is in this case 2, tan inverse of u over a, so that'd be x plus 5 over 2, and then plus some constant c, okay? And really, there's no cleaning up for that. That's it. That's the answer. Okay. And that's example 2. Okay. So for this next example, what we want to do is we want to get it to look like example 2. And the way we're going to do that is we're going to complete the square. Okay. So we have x squared minus 4x plus 7. And we want to integrate 1 over x squared minus 4x plus 7. So I'm going to start completing the square. So I'm going to start with my x squared term. And then I know that I'm going to put half of the x terms here and the other half right here to make my square, right? So this is going to be half of negative 4x. And it's going to go here and here. Okay, so that would be negative 2x, right? So negative 2x here and negative 2x here. And this makes x by x. And this would have to be minus 2. And this would also have to be minus 2. And negative 2 times negative 2 is positive 4. So my missing piece right here is the 4, right? So I need to decompose the 7. And what do I need to decompose it into? Well, I need to decompose it into at least 4 and then plus something else, right? Or maybe minus something else. Well, we want 7, right? So it's going to be 4 plus 3. So this is going to be the integral of 1 over, and we're going to break this up into x squared minus 4x plus the 4, right? But now we don't have 7, right? We don't have 7 now. We have plus 4. So we need to add 3. I'm going to extend my fraction bar a little bit, and then dx. Okay, so these 3 pieces make up my perfect square. Okay, so this becomes the integral of 1 over, and these 3 pieces make up the x minus 2 squared. So x minus 2 squared plus 3 dx. Now the order is a little bit wrong, but because it's addition, I can change the order, all right? And so this becomes the integral of 1 over, okay, 3, right? It's going to be 3. But what would it be squared, right? What do I square to get 3? Well, I would square the square root of 3. Okay, so the square of the square root of 3 would be 3. Okay, so if these aren't perfect squares, they're going to our a is going to wind up being a square root. Okay, and then plus x minus 2 squared, and then dx. And then by looking at this, I can tell my a is the square root of 3, and my u is going to be x minus 2. And it takes on that form that we saw earlier. Okay, so this is going to be 1 over a. So that'd be 1 over the square root of 3, arctan or tan inverse, whichever one you want to write, tan inverse of x minus 2, because that's my u, over my a, which is the square root of 3 plus c. Now, this is a fine answer. It's a good answer, but it's not the best answer, okay? Because we don't really want to leave square roots in the denominator. So we're going to multiply this one by square root of 3 over 3. So the best and final answer would be this becomes the square root of 3 over 3 tan inverse of, and this one we're also going to multiply the square root of 3 over the square root of 3. So this becomes the square root of 3 times x minus 2 over 3, and then plus c. Okay, and that's the best and final answer. For this final example, okay, what we're going to want to do is we are going to want to factor out this 2 out of all 3 terms, okay? So this is, before we complete the square, okay? So this becomes the integral of 1 over, and we're going to factor 2 out of all 3 terms, 2 times, and this becomes x squared plus 6x plus 14, and then extend my fraction bar a little bit, and then dx, okay? Now, what that's going to allow me to do is this actually is going to become 1/2, right? We're multiplying by 1/2. So this is the integral of 1 over 2 times 1 over x squared plus 6x plus the 14 dx, all right? And this 1/2, I'm going to be able to do is pull it out in front, okay? All right, so now what I'm going to do next is I'm going to start completing the square because it's ready to go now, okay? So I have an x squared, and that's what allows me to do completing the square, okay? I have an x squared, and I got to put half of my 6x to the right of the x squared and underneath, right? And this is half of 6x. So this would be 3x and 3x. And so this is x plus 3. And this would also be x plus 3. And 3 times 3 is 9. So that's the little piece that's missing to complete the square, to finish off the square, right? We need a 9. So this 14 can be broken up, right? So I'm going to pull the 1/2 out. So this is equivalent to 1/2 the integral of 1 over, and then this is going to become x squared plus 6x plus 9. Extend my fraction bar a little bit. Okay, but now I don't have the 14, right? I have 9. I need 14. So what do I need to add right here? I need to add 5, right? And then dx. Okay, so this becomes 1/2 the integral of 1 over, this is going to become x plus 3 squared plus 5, and then dx. Now the order is not right, okay? And also this isn't a, we need to rewrite this as a square, okay? So this can be rewritten as 1/2 times the integral of 1 over, okay, so what could I square to get the 5? I could square the square root of 5. So the square root of 5 squared, that would be 5, and then plus x plus 3 squared, and then dx, okay? So I know from looking at this, I can tell my a is the square root of 5, and my u is x plus 3. Okay, I'm going to slide this up a little bit. All right, so from our format, this is 1/2 times 1 over a, so that'd be 1 over the square root of 5, tan inverse of our u, which is x plus 3 over a, which is the square root of 5, and then plus c, okay? Now, this isn't, and this could be written as 1 over 2 square root of 5, but I want to simplify this one, right? So this 1 over the square root of 5 becomes the square root of 5 over 5. So this is 1 over 2 times the square root of 5 over 5, tan inverse of, and we don't want to leave square root of 5 in the denominator here either, okay? So I'm going to multiply top and bottom by the square root of 5, and so this becomes the square root of 5 times x plus 3 in parentheses over 5, and then plus c. And then the final answer would be this, okay? So multiplying these two together, we'd get the square root of 5 over 10 tan inverse of the square root of 5 times x plus 3 over 5, and then plus c. And that's the integral of 1 over, and I'm going to zoom out a little bit. So that's the integral, and I zoom out a little bit more. Okay, so that becomes the integral of 1 over 2x squared plus 12x plus 28, okay, becomes the square root of 5 over 10, tan inverse of the square root of 5 times quantity x plus 3 over 5 plus c, okay? And now we're going to look at one other type that we need to complete the square on, okay? So I'm going to finish this. I'm going to break this into 2 parts today, okay? So this is going to be part 1, and then we're going to have a part 2, okay? And the next part is going to be part 2, all right? So stay tuned.